Hello, good afternoon, good evening. Um, I see that we are live right now. Sorry for a little bit of delay that we had. So today session was all about building a real-time rack solutions. So I just wanted to be able to do an experiment to see if there's a way that to use the rack technology or retrieval augmented generation technology on a real-time basis. Um, the prototype that I'll be building today, it's a very basic prototype and it's just an experiment. uh, Hopefully we can expand on it, and in the future I can build on top of it and add more complexity around the architecture. But for today's purpose, I'm just going to go through the build. I'll be sharing my screen, so you will follow on that. And as I show the code, I will also be deploying this to a Kubernetes cluster. So I will also go through the process of deploying that and step by step on how did I build that components. So without too much delay, let me open up the VS Code. um, See if I can share my screen. Okay, all right, perfect. So let me see if my screen is available. All right, so and let me just put this in the background. So yeah, you might not see me, but yeah, I will be just presenting that directly on the screen. Just to get us started, basically just the basic structure of what we need. We need a way, and I will draw this out as well on a draw.io. But we basically need a way to forward, and I chose Kubernetes because it was a primary system that I could just get logs from. But in another word, you can do it with application logs, you can do it with system logs, IoT logs, any type of logs, any sort of real-time data that you can get. It's probably possible. So for the purpose of this work, I selected a Kubernetes cluster where I can build a simple um, uh, log forwarder. So I can just install a log forwarder that would send the logs to my um, uh, specific API endpoint that will all be showing the build as well. So if you see my the draw.io page, so I will be drawing this out. So this is my Kubernetes cluster basically. And on top of my Kubernetes cluster, I will have multiple components. One of them would be the log forwarder. In this case, I'm selecting Fluent Bit. It's a very lightweight open source log forwarder that I can install quickly. And for the purpose of this, I'm already installed that. So if I go to my cluster, if I do a kubectl get nodes, you see I have a very small cluster, 2 worker nodes. And you will see that if I show it here too, you will see that FluentBit is already installed. So I already have it installed, but I will go through the configuration and everything at the same time. Alright. So in this case, you have the FluentBit that's already installed. It's sending the logs. To my Python. So I'm building that via the Python. So it's a Python Flask, and it's basically an API endpoint, and my API endpoint is logs/logs. So I need a way to for this to receive logs, and as an input, I'm just sending entire string. In this case, I'm sending actual JSON. So whatever format that is selected on this side, and I'll show it to you, there's a way in configuration where you can say this is the format that I want to be forwarded from FluentBeat to my API endpoint. And then, so just to remember that FluentBeat is also a Kubernetes cluster, so it has multiple components to it. One of them that's important, that's built on top of the FluentBeat, is its config map. Because the config map is where you have all the configuration, and I'm going to be showing to you how to set it up. But yeah, you have the config map, you have the pods. In this case it's a daemon set, because it's running on all the nodes and it's reporting all the logs, so it's basically running on each node. As I saw, I had 2 pods. And then there is other components that I will not go through, but most importantly, just to know that this is a daemon set, and it also has the config map set up here. And then, so once the logs are forwarded to my Python logs, here in this application there's also a subcomponent to this where you need to process the logs. So first, if you need to do any sort of a cleaning, cleaning, tagging, chunking, any sort of like data cleaning kind of activities that you need to do, you can actually do that as a subtask. And then once you clean the data, you converted it, you changed it, that's where whole the rack solution comes into the place. In this case, I'm building a small in-memory rack solution, so I'm using an in-memory database called Phase. Okay, and then I'm using Llama Index as the framework to be able to connect to the Phase. So ingest the data. So in this case, once I clean the data, I will pass it to Llama Index, right? And then I will be using a LLM model. In this case, I'm using it to embed it, so I need a model to embed it. So I'm using a local host embedding model, right? So Llama Index uses that, then ingests the data to the Phase, right? Sorry, not this one. The data comes back to the Llama Index, then Llama Index sends it to the Phase. Okay. And we'll go through all of these steps. So that's for the storing the data, right? And then in this flow, you also need to be able to there's the second subcomponents to those, and those are to be able to retrieve the Retrieval Augmented Generation. That's where the part comes from. Is to be able to send it to another model, which in this case for us is the OpenAI, and in this case is hosted on a Azure infrastructure. So we have the Azure cloud. Okay. And then on top of that, we have a privately deployed OpenAI model. Okay, so this is the basic. And then again, we are using Llama Index to, send the query. So in this case, is a list of problems or list of alerts that we want to monitor. So if there is something that we want to constantly monitor, right, let's call it the query. So it's gonna send it's gonna basically send that first to Phase, comes back with the data, right? I don't want to spend too much time drawing, but just know that the data comes back from phase. So basically you send the query first, you retrieve it, comes back to the llama index, it gets sent to OpenAI model, right? The OpenAI model comes back with the response to the application. Right, I'm not going to draw it out, but you know to understand the point. Alright, so all of that has to happen in the memory, and then at the end, it gets rid of the entire storage, because there's batches. So there's like quick batches, and there's quick analysis on each batch, right? And those batches are quick, and as we built it, you're gonna see that it's very quick. So let's get into the code. In this case, I have a folder called logs app, so I'll focus on this. And if you see, there's a very simple app.python. I will go through that. So as I mentioned, I'm using a local model to be able to embed the input that I'm having. So I'm using the Hugging Face embedding model function, and I'm using this specific embedding model to be able to do that. I'm using a chunk size of the 512, and I'm chunk overlap of 50. Okay, and it's very simple. I kept everything in one file. It's 86 lines of the code, and so we have the /logs endpoint. We have the process logs function, right? That's what I'm saying. If you have any sort of cleaning that you need to do, any sort of things that you need to do, that's where it happens. In this case, I'm converting the data, because the data comes in as a JSON. Then I need to convert it to the JSON string so that it can be imported as a document. That's where I initiate a vector store, a local using the phase vector store, a llama index function. I created a storage context, and then therefore I create the index, and I store the index by calling this function on the line 60 to persist the data. And that's where there's going to be a folder created here called data. That's where it's been stored on the memory on a short-term basis. And that's where the folder called persisted dir. And then so once that's stored, and that's where the rack starts. So the rack part starts from here. I'm making a query here. So first of all, I'm initiating a query engine, and I'm saying what does the error mean. So this is a very simple query, but you can have multiple ones, so you can monitor for different issues, but as a simple natural language, right? So you can set your alerts with the natural language, instead of trying to define specific rules on when that happens. You can do that. You can just say, when the memory is high, just tell me, so, and they would be able to detect it. And it's doing that continuously on the real-time basis. Alright, so in this case, let's get into the fluent bit. So in this case, I need to build it actually as a Docker file. So I have a Docker file included as well, which basically builds a very basic, simple Flask app that I can deploy on my Kubernetes cluster. So going back to that diagram, that Python app is actually on the Kubernetes itself. So if I wanted to kind of show it to you here, this Kubernetes cluster is going to expand. So basically this Python app is also deployed on the Kubernetes, and it's communicating with the log forwarder. It can be also external, anything like that, but in this case, I'm just, for the sake of simplicity, I'm deploying it on the same infrastructure. Okay, so in this case, I built it as a Docker image, I tagged it, and then I have my deployment. So this is my deployment of my Python app. with the slash logs endpoint that I can consume at any time. Right, I'm passing a secret for connecting to the data, connecting to the OpenAI API and all that stuff. So keep it in a secret, and I mount the secret to the deployment, to the pod, to the container. And if you see it, that's where I define the image, and I call it the kuberag because I'm using the basic structure that kuberag provides, and I'm defining the secret name here. I have a very so my second node is actually I'll go through the specification of the memory and the CPU, but it's actually a more powerful node in terms of compute, and I want this application to specifically run on that node that I have enough resources. So I'm hard coding the node selector just to say that I want it to be scheduled on that specific node. My other node cannot handle this application because it's a very memory intensive application. Even though I define the resources here as 5 GI and then the limit of 6 GI. Alright, so if I deploy this right now, this will be opening up the slash logs, and then on the fluent bit side, what I'm configuring is basically I'm just right now I'm as an input I'm getting all the system logs, all the container logs, but you can potentially expand on it and get more inputs from different components and different part of the system. You can also apply filtering. I just use the basic and default filtering that is available, and then that's where the important part comes from. So that's where I define my output. I'm simply saying that I want it to be a HTTP request to a specific host. I want it to be on a specific port that I defined, and to that slash logs endpoint that I defined earlier. Going back to the earlier time where I mentioned what kind of format of the logs is going to be. So in this case, I'm selecting JSON as a format to be sent to my slash logs, and that's what I'm expecting. And then there I'll convert it back into a string where I can use it directly into the Llama index. And then I'm defining the application slash JSON specifically just to say that. And as I mentioned earlier, so there is the config map, and in this config map, that's where I define this exact same things. So if I do a kubectl you see the exact same stuff. And then so you might question, where is this IP then that host comes from? So this is my Flask application here. And then in this Flask application, I'm defining deployment, but I'm also defining a service because I might have to deploy this multiple times, and the IP of the pod might change. So I'm using a service, and so that way I can guarantee the IP address that I have for that. And then if I need to redeploy and destroy the pods, I can do that on demand. And that's why I'm doing this. So I'm since my Flask app is on a port 5000 here, I'm defining the port forward. So I'll go ahead and I'll deploy this. I think I partially deployed part of this. So if I look at the services, see, I can see that there's already a service, and that's the IP that was configured on the float bit. But if I see if there is any deployments, I see that there is no deployments in the default namespace. So I'll go ahead and deploy this. And we'll see here. Yeah, and then I figured out how to put my screen on top back again, so you might see me again here. So if I see here, so I see my pod is actually running. Kubernetes agent deployment, and if I look at the logs, I see that I'm getting couple of calls. See, excellent. So this is actually good news. So the message here is that this is a please see the response here. So this is actually the response coming back from the LLM. So saying there is no error present in the provided log entry, the log indicates a successful HTTP GET request. So far it has not detected anything. So this is actually coming back from the initial query that I mentioned here. What is the error? So what does this error mean? So this is the response from the LLM, and it's continuously checking that. So if I do that, if I continuously look at it, see it's continuously the fluent bit is sending. Let me see if I can open up the. Okay, I cannot do that. Okay. And then if I stop this and look at the fluent bit pods, those are the ones that are sending the system logs. Oops. Perfect. So I can see that those are being sent. Cool. See, those are HTTP client server close 200. Those are my IP address of my pod. So it's actually sending it. Perfect. And then on that side, I'm looking at it, that I'm receiving it, and I'm constantly sending that to OpenAI, analyze the error, logs, comes back. So it's really efficient as well, because it's doing a small vector search on the local basis, and then based on the generation of real-time API of the OpenAI, it's able to respond quickly of if there is an issue. In this case, I have not simulated an error message or any problem, but I imagine if there is any sort of issues that comes up in the logs, it will be able to detect it. And you can also expand on the query, because it's a natural language, so you can possibly kind of put any sort of analysis example that you can think of. So what does this error mean? Can you expand on it? If you detect any HTTP error, if you detect any application error, memory issue, you can say that all of those as a natural language. I'm just gonna experiment with different stuff. Perfect. So this was the initial build, and it was really simple, and it's actually not consuming too much money in terms of the cost for that, because when I checked earlier, since we're using the ChatGPT, smallest, most affordable model, it's really not costing us that much. And since we are controlling the size of the batches that we're sending, so we are limiting also the tokens that we're consuming on each API call. And then so we have this control with the fluent bit or any other sort of log forwarders to limit the amount of the logs that we're sending, to chunking them, so different aspects of it we can control. In that Python app, you also have the different abilities to use the metadata, extract the metadata, add additional stuff to make the search even more efficient. So that gives you also a lot of freedom to do that as well. With that, I think that's it really. This is all I wanted to present, and that was just an experiment. I'm not sure if this is the correct way of doing it, but I think the more complex part of it, if you could make it more event driven, so have certain events that can be detected on So instead of running it constantly on the real-time basis, which you can, and that was the whole purpose of this, to show it, but do it more on an event-driven type, where if there is some sort of really an error message that's detected, therefore trigger this whole process and then come up with the answer. But this is also, that was just to be able to show it. Hopefully in the next examples I can expand on it and I can show you actually some real examples where an application fails and this is able to detect it and come up with the explanation of what the actual problem is. With that, thank you very much for joining. I have the all the details of the code that I shared earlier here on the LinkedIn article, so you can actually access it, and if there is anything you can let me know and send me a quick message on the LinkedIn or email, and I'll be able to respond to you as quickly as possible. So thank you for listening into this live session. Hopefully it was provided you with some examples and some stuff that you can also try on your side, and if there is anything, let me know as well. With that, have a good night, and hopefully we can talk again in your future.